it's over. So we are going to the next numerical. Okay. Next is for triangular channel. Okay. Next question is find the normal depth of a triangular channel. That is what we need to find out the depth of flow. Okay. Having the slope of 4 into 10 to the power minus 4. Slope, that is longitudinal slope, is nothing but your bed slope. Okay. That longitudinal slope is nothing but your bed slope. Okay. So what we need to find out? We need to find out the y. That is your depth of flow. Why we need to find out? Question mark. Okay. Bed slope is given 4 into 10 to the power minus 4. Side slope is also given 1 is to 1. Okay. And when it carries, that is discharge. Discharge is given 1 meter cube per second. And we have given Bannings n. Okay. So we need to find out the n value. Okay. So you kindly try to solve. Okay. This slope is given. So depth of flow we need to calculate. Bed slope is given. N is given. So first you use the area equation, half into base into altitude. Okay. So this is similar to your previous case what we have discussed as your 1 is to z. Okay. If you consider the side slope is 1 is to z, 1 is to z, then this will be your zy. Okay. Similarly, if you consider this triangle, this will be your zy. Okay. So if you consider the area equation, half into base into altitude, as this is a triangular section, half into base will be your twice zy multiplied by y. Okay. So 2 will be cancelled out, equal be zy square. Okay. zy square y square. Okay. Area will be zy square. Okay. So here it's not visible properly, so that is why zy square. Okay. Area is zy square, and you see our z is equal to 1 in this situation. Okay. In this problem your z is equal to 1. Okay. So we substitute z equal to 1 and we will get area equal to y square, since z is equal to 1 for the given numerator. Okay. Then we try to find out the weighted perimeter. Okay. So if we consider the triangular channel, okay, if this is a level of water, so this side we are going to consider and this side. Okay. So like Pythagoras theorem, you find out one side and you multiply it by 2. You will get a weighted perimeter. Okay. So depth of flow is not known to us. So that is why this is zy. So if you do the Pythagoras theorem, and what you are finding out, root over zy whole square plus y square. Okay. And as we are considering this weighted perimeter, we multiply it by 2. Okay. And finally, you will get an expression like this: twice y root over 2. Twice y root over 2. Okay. Then we need to find out the r. R is nothing but area by weighted perimeter. Area, we got the expression y square divided by twice y root over 2. Okay. So this y will be cancelled out. So will be left out y by 2 root 2. Okay. Then we have taken the equation of discharge. Okay. As discharge is given 1 meter cube per second. Area again y square. Okay. See, as it is called normal depth, that's why I have taken y suffix n. You can directly write y also. No issue. Okay. Y square. Again, for calculating velocity, as Bannings equation is given, we have used Bannings equation. Okay. So 1 by n v equal to 1 by n r to the power 2 by 3 s to the power half. Okay. So this will be y square plus 1 by n. In place of r, we can substitute this equation. Okay. Y by twice root 2 to the power 2 by 3. Okay. And slope is already given, longitudinal slope, or you can say bed slope, that is 4 into 10 to the power minus 4. Okay. Then you do the simple calculation, and from here, as we have one equation, you can see in this equation we have one equation and one unknown. Okay. So you can find out the that unknown term. Okay. That is why you try to calculate and see you are getting the same value or not. That is yn equal to 1.13 meter. So you people are getting the value for depth of flow. Depends on what is given. Okay. If Sage's constant is given, then you have to go for Sage's equation. Okay. Or if Bannings constant is given or Bannings coefficient is given, then you have to use Bannings equation. Okay. For velocity. Value is 1. This z value is 1. Okay. Z is equal to 1. Okay. Okay. So when your side slope is given 1 is to 1, you always remember your z is equal to 1. Okay. So you try to solve this equation, solve this problem. Here also you need to find out the discharge. Here also you need to find out the discharge of a trapezoidal channel, width of the channel is given 10 meter. Width of the channel is given 10 meter. You did not to write the whole numericals. Okay. You directly just write the given data. Okay. That is your what you need to find out, that is discharge. Discharge is question mark. Then it's given trapezoidal channel. Width of the channel is given 10 meter. Side slope is given 1 is to 1. Depth of flow is given 2 meter. Okay. Depth of flow is given 2 meter. Slope is given. Slope is not visible here. Let me see here. Okay. Okay. Slope is nothing but your 10 to the power minus 4. Okay. Slope is 10 to the power minus 4. Okay. Here. Slope is also given. It's 10 to the power minus 4. Okay, of a trapezoidal channel, the width of the channel is given 10 meter, side slope is given 1:1, depth of flow is given 2 meter, and longitudinal slope, or you can say bed slope, is given 10 to the power minus 4. It's not visible, you just write it down, 10 to the power minus 4. And Manning's n is given 0.02. Then you find out the discharge. Then you have to use Sage's equation, and you have to calculate Sage's coefficient. Okay, so you can draw a trapezoidal section. Okay, so during examination, you draw or not, it depends on you. Okay, if you don't want to draw this trapezoidal section, then it's up to you. Okay, so the first step, we need to find out the top width. Okay, so as I have already told you that if it is 1:1, our z is equal to 1. Okay, if z is equal to 1, y value is given 2 meter. So that is why 2 plus 10 plus 2. Okay, that is your 14. Very simple to calculate. Okay, so here y is 2 meter multiplied by 1, that is 2 meter. 2 plus 10 meter plus 2 meter, then you can directly write 14 meter your top width. Your top width is your nothing but your 14 meter. Okay, so whenever you have a side slope of 1:1, it's very simple to calculate top width. Okay, so you can directly calculate and substitute 14 meter, and plus 10 meter is your bottom width, divided by 2, multiplied by vertical distance, that is your again 2 meter. So this 2 will be cancelled out. So area is your 24 meter square. Okay, okay, so yeah, try to solve this equation. Sorry, try to solve this numerical, and then we will discuss its answer in the next class. So, so here we have to show that. Okay, or you can say we have to prove. Okay, so what is given, we need to prove about the normal depth. Thing nothing but is, you can write y. Okay, in a triangular channel. So it is given as a triangular channel. Side slope is given, z horizontal is to 1 vertical. Okay, and this is the expression. So what we have to do, we have to prove that yn, that is our normal depth, in a triangular channel, when the side slope of the channel is z horizontal is to 1 vertical, is followed by this expression. Okay, is followed by this expression. So kindly you write down the equation. Okay, over. Okay. So this is the equation we need to prove. Okay, that is yn is equal to 1.189 multiplied by, this is discharge, multiplied by Manning's coefficient. Okay, small n, divided by root over bed slope to the power 3 by 8, again multiplied by z square plus 1 divided by z to the power 5 to the power 1 by 8. Okay. Okay. So you can draw this diagram. Okay, it's a triangular section. It's given the equation. Then the side slope is given. Z horizontal is to 1 vertical. Okay, Z horizontal is to 1 vertical. So that is why we have taken 1 by Z. 1 is to Z. Okay, 1 vertical and Z horizontal. Okay, the whole angle for that particular triangular section we have considered theta. Okay, and this line, the dotted line we have seen, is divide the whole triangular section into two parts. Okay, so that is why it also divide the angle theta into two equal half. Okay, so for this side your angle is theta by 2, and for the other side it is again theta by 2. Okay, then we have marked this point as A, this is your B, and this point is C, that is your bottom of the channel, and this point is nothing but your D. Okay, and the depth of flow we have considered Y. Okay, so similarly we have already discussed this will be your YZ, or you can say ZY. Okay, same thing, ZY, and this is also ZY. Okay, from here to here is ZY, and from here to here again it will be ZY. Okay, okay, so now we are going to consider this triangle. Okay, this triangle. So definitely this is your 90 degree. Here it's 90 degree. Okay, So we draw like this. Okay, this is your 90 degree. So the 90 degree is at point A, right? So this will be your A. Okay, and this will be your B. So this is your B, and this is your C. We join. Okay, so this is a right angle triangle. You can see here. This is a 90 degree. This is a right angle triangle. Okay, so here A B is nothing but your ZY. Okay, or you can say YZ. It's up to you. A and A B, that side is your YZ. Okay, and A and C is nothing but your depth of flow. AC is nothing but your depth of flow, that is Y. Okay, so that's why we have taken Y here. Okay, and we have already discussed the whole angle C. Okay, so that's why this angle is theta by 2. This angle is theta by 2. Okay, so we are considering this triangle, and we have the two side, and we are going to find out the other side, that is your BC. Okay, so definitely we are going to use our Pythagoras theorem to find out the side BC. Okay, so there is nothing but our square root zy square plus y square. Okay, so here that y square, and again we have y square, so we will bring it out, and we will get y root over z square plus 1. Okay, z square plus 1. Okay, z square plus 1. This is nothing but your BC. This side. This is nothing but root over z square plus 1. Definitely we have a y. Okay, y root over z square plus 1. Then we are going to consider tan theta. Okay, now we are going to consider tan theta. Then here the theta is nothing but theta by 2. Okay, so tan theta is equal to perpendicular by base. Okay, perpendicular by base, and then perpendicular is nothing but zy. This is our perpendicular, and this is our base. Okay, so perpendicular is zy and base is y. So this y is will be cancelled out, or what will be left out is z. Okay, So we can directly write here tan theta by 2 is nothing but z. Okay. So similarly, we are going to find out sec theta by 2, that is BC by y. So BC we have already calculated, y root over z square plus 1 and then divided by y. Ultimately, we are getting root over z square plus 1 for sec theta by 2, and for tan theta by 2 it's z. Okay. From here you can also write BC is equal to y sec theta by 2. Okay. To write down its expression from here, okay, as sec theta by 2 is BC by y, so you can write BC is equal to y sec theta by 2. And what is sec theta by 2? It's root over z square plus 1. Okay. Okay. So now we are going to consider the area. Area, okay. Area is nothing but half into base into altitude. So here it is a triangular channel. So the base will be this from here to here, our top width. Okay. In triangular channel, our bottom width is 0 and we have top width. Okay. So that will be our base. So definitely this is your YZ and this is also YZ. So that's why we have taken twice YZ. Okay. Multiplied by the depth of flow Y. Okay. So that is why 2 will be cancelled out and Z is there and Y into Y is Y square. Now considering triangle ABC that we have already did, okay, then we are going to consider the weighted perimeter. Okay, for weighted perimeter, this is D. So weighted perimeter is nothing but DC plus BC. Okay, this is our weighted perimeter. This side and this side. Okay, weighted perimeter till here, till the level of water. Okay, so here this is weighted perimeter. Weighted perimeter. Okay, so definitely this side and this side will be same as our side slope is same. Okay, so that is why we have taken twice. We know BC is nothing but our y sec theta by 2 and BC and CD will be same in this case. Okay, because the side slope is same, all the parameters are same. Whatever we are going to get for BC, we will get for CD also. So that is why we have multiplied by 2. Okay, twice y sec theta by 2. Okay, from here you can say BC is nothing but y sec theta by 2. Okay, okay, so we have get an expression for weighted perimeter. We have get an expression for area, that is your zy square. So now we are going to take discharge equation. Okay, See why we have taken research equation, because if you see in that expression that we need to derive, you see we have q there. So okay, so somehow we have to bring q in that particular expression. Okay, understood. So that's why we are considering this research equation. Okay, so that we can get an q in that particular expression. Okay, so this will be q. Then we have already, for area we have equation is zy square. Okay, area is nothing but zy square in this case, and then theta by 2, then theta by 2 is equal to z. We have already. Okay, so it's zy square. In place of z we have substitute tan theta by 2, so we can write y square tan theta by 2. Okay, then velocity. Okay, see for velocity we have two options. One is Sage's equation and one is Bannings equation. But in that expression that we are going to derive, we have small n, that is our roughness coefficient, Bannings roughness coefficient. So that is why for velocity we are going to use Bannings equation. So we all know that Bannings equation is 1 by n multiplied by r to the power 2 by 3 multiplied by s to the power half. Okay, so if you see in that expression we don't have any term as r. Okay, we don't have any term as r. Okay, so we don't have any term. So what we have to do, we have to replace this term hydraulic radius. Okay, so we have n in that expression, we have bed slope in that expression. If you see in that expression we have a term n, we have bed slope, but we don't have any r. Okay, we have y. Okay, y is the ultimate parameter that we are going to derive. Okay, for y what will be the expression? So definitely y will be there, but that r is not required. So what we do, we consider r is equal to area by weighted perimeter. Okay, so in place of r we are going to substitute a by p. Okay, for area we have already calculated the expression, derive the expression for area and for weighted perimeter also. Okay, so in next our left hand side we have q, and then what we are going to do, we bring n and our bed slope in the left hand side. Okay, of this equation. So if we bring it left hand side, as it is in divide, we have to multiply it here. Okay, you can see here q multiplied by n. Then if we bring here, it will again divide root over sb. Okay, you can write simply as, or you can write also as b, it's up to you. So it's to the power half, or you can write root over sb, same thing. Okay, then is equal to this y square tan theta by 2 will be left out. Okay, area multiplied by, in place of r we are going to substitute a by b, area by weighted perimeter. So area is nothing but, we can write this expression again. Okay, y square tan theta by 2, then divided by weighted perimeter. We have already found out the expression, that is twice y sec square by 2. Okay, sec theta by 2. So y square tan theta by 2 divided by twice y sec theta by 2. Okay, so to the power 2 by 3. Okay, so that is y square in the numerator, and denominator we have y. So one y will be cancelled out. Okay, then in the next expression, sorry, next line, left hand side will be same, and right hand side this will be kept as it is, and the second part y will be cancelled out. So that is why y tan theta by 2 twice sec theta by 2 all to the power 2 by 3. Now in the next line, we bring that 2 in the left hand side. Okay, so it will be divide. So we'll bring here in the left hand side, it will be multiplied, and you don't forget we have 2 to the power 2 by 3. So that is why it will be 2 to the power 2 by 3 is equal to, again this is already there, y square tan theta by 2 y square tan theta by 2 is already there, multiplied by this y to the power 2 by 3 okay? So that is why y to the power 2 by 3, and then tan theta by 2 to the power 2 by 3. Okay, divided by this 2 is already, we bring it out in the left hand side, so it will be left out sec theta by 2 and to the power 2 by 3. Okay, again in the next line, left hand side we kept as it is, right hand side, so we have y square, and here y to the power 2 by 3. So y square multiplied by y to the power 2 by 3. Okay, so is equal to nothing but y to the power, we have to add, right? We have to add 2 plus 2 by 3 is equal to y to the power 8 by 3. Okay, so that is why we have the addition. Okay, you can see this y to the power 8 by 3. Okay, then we have tan theta by 2 here, tan theta by 2 multiplied by tan theta by 2 all to the power 2 by 3. So that is why it's 10 theta by 2 to the power 5 by 3. Okay, this is nothing but 10 theta by 2 multiplied by 10 theta by 2 whole to the power 2 by 3. Okay, so we have to add here. We have 1 and this is 2 by 3. So 1 plus 2 by 3 it's 5 by 3. That is why here it's 5 by 3. Okay, and the denominator will be same. So then all the terms except y to the power 8 by 3 we bring in the left hand side. Okay, because we have to derive the expression for y. Okay, so we have kept this y in one side and other all the parameters we bring in the left hand side. Okay, that is why it is in the numerator and this is in the numerator. Okay, then after this we have taken cube in both side. We have taken cube in both side. Okay, so we have cubing both hand side, that is left hand and right hand side. Okay, so that is why 2 to the power 2 by 3 to the power whole cube. Okay, this is also whole cube. Then again this term is also whole cube and this is also whole cube. Okay, so this is 2 to the power 3 into multiplied by 3. So 3 will be cancelled out. It will be left out is 2 square. Okay, this is cube and then again this 3 will be cancelled out. It will be square and to the power 5. Okay, and this will be y to the power 8. Okay, so we all know 10 theta by 2 is z. We have already derived, and sec theta by 2 is nothing but root over z square plus 1. Okay, we have already derived this. Okay, for our this case. Okay, for this numerical 10 theta is our equal to z and sec theta by 2 is equal to root over z square plus 1. So now we are going to substitute this term, because if you see in that question or in that expression that we are going to derive, we have the term with z. Okay, so we have to bring z in that particular expression. Okay, so that is why here sec theta by 2 is whole square, so we can directly write z square plus 1. Okay, root over will be, because it is square. Okay, so directly we will write z square plus 1 divided by, as 10 theta by 2 is z.
All are requested to give your attendance in the chat box. Okay, and this meeting is going to over, so you all are requested to kindly join in the same link. Okay, okay? So join again with the same link. Okay, then kindly give your attendance in the chat box. Write your enrollment ID.
z to the power 5 is equal to y to the power 8. Okay. I think this thing you already know, y to the power 8. So if we want to find out y, so we have to multiply each and everything with 1 by 8. Okay, so that is why it will be 3 by 8. Here also to the power 1 by 8, 2 square to 2 to the power 2 by 8. Okay, bring this y in the left hand side. Okay, to get yn. Okay, so after you solve, you will get this expression. Okay, so you go through once again and see if you have any doubts. Okay, if you have any doubts, then we will discuss here. My suggestion is go through once again. Okay,
So all are requested to join again, okay, with the same link.